Okay. Just tell me when you want me to do my intros.
Well, do that at 6 o'clock sharp.
Okay.
Yeah, this is that's the equipment. We're gonna have to.
Oh,
It's like the same as the last one, except with the slightly more expensive mount and camera with the two.
fabulous. Look at that.
Okay, let's go back to this.
$5.59. Are you ready, Vivek?
Yeah, is it 6? Okay, we have 10, so I guess we can start now.
Okay. Good evening, everyone. On behalf of Julian Dark Sky Network, we welcome you to a wonderful star party tonight. It will feature our galactic guides, Vivek Vijaya Kumar, who is currently a senior in high school. Vivek has been hooked on astronomy since he was 8 years old, and he went from the hobby side to the interest in the scientific part of astronomy. He has received numerous awards, both at the county level all the way to being awarded to participate in 2019 in the summer program of the Max Planck Institute in Heidelberg, Germany. He has won several awards for his astro imaging, and the dark skies of Julian brought him to Curiosity Peak, and he's broadcasting from Curiosity Peak in Julian tonight. Our other galactic guide is Professor Scott Cardell, the professor of astronomy at Palomar College. He is the assistant director of the planetarium there. He previously was at the International Dark Sky Association and previously worked also at Palomar Observatory. Julian Dark Sky Network is in the process of seeking their application for International Dark Sky Association community, and we will keep you posted as to when we receive the recipients, the happy recipients of an IDA designation. We expect to see the following tonight: the moon, of course, the Flaming Star Nebula, the Monkey Nebula, Orion Nebula, Rosette and Flame, the Rosette Nebula, Dry Nebula, and the Cone Nebula, depending on how the wind shift and we are able to focus on them. If you want additional information on us, please go to the Julian Dark Sky Network Facebook page, which is the official Julian Dark Sky Network Facebook page, or visit us on our website, juliandarkskynetwork.com. Welcome again, and have a wonderful evening. Sit back and enjoy both our presenters and this wonderful sky view.
Thanks, Lynn. I appreciate the introduction. Vivek is running the telescope there, and obviously I think most people can see we're pointed at the moon. Maybe you wanted to say a little something about what we're using tonight, or the view, whatever you'd like to say.
So, if people remember the previous star party we did that relates to the winter sky, we were doing it with a more shoestring type of approach. So what we're doing now is a little bit more expensive. It's basically the same telescope, but we put it on with more accurate tracking with a nice mount and a cooled camera so that we can really get some good views on some fainter or some of our more familiar objects. So this is basically a 5-inch with the cooled color camera on a go-to mount. So we're going to be using that tonight. And
awesome.
Right now we have that on the moon. So let me zoom in a little bit. And I guess we can start here. It's right now a little bit low on the sky. It's 30 degrees above the horizon, but and that's why you can quite see this kind of shimmering effect, is because the atmosphere is interfering with it. But we can see a lot of details such as craters and moons on the moon.
Right. We're looking at what's called the terminator, that line between day and night. And when you look at the moon from night to night, say if you caught it yourself outside this evening and you watch it over the next week or week and a half, basically you're seeing sunrise happening across the face of the moon. It's kind of cool. And whenever you look with a telescope right along this line, that terminator, that's where the shadows are long, so the craters look deep. The mountains look higher. There's more relief to see there. It really adds to the view.
And so yeah, going off of that, when you as we progress through the phases, the terminator shifts. It goes more to the west of the moon. So you can basically get all of that detail that's on the terminator contrast as the phase changes. And during full moon, which is typically when a lot of people decide to see the moon, the sun is top down, so there's not much contrast or shadows. So in order to see that relief, you have to look at some of the phases that apart from full moon.
Yeah, full moon is pretty much the worst time to look at the moon through a telescope. Maybe it's more romantic out outside at night, but if you want to see anything other than just intense brightness, full moon's not really the time. And the view now, we just shifted it, but even this, I know what you're going for. Go ahead.
Yeah, there we are.
Yeah, now we've changed our view pretty dramatically there. And you can see what's called earth shine over there on the left. That's literally reflected light off of Earth shining back onto the moon. Pretty zoomed in there.
Yeah, when you said brightness, I had to go for showing the earth shine part. Yeah.
Yeah.
But
so literally, yeah, that is light reflected off of Earth. Light from the Pacific, basically, right now, shining toward off of the Earth and back towards the moon to light up this portion that we can see. It always makes it nice when we have a crescent moon that you can see these details in the Earth shine. And now that we're zoomed in right on the edge of the moon there, right at the terminator, you can see that bright spot down there all by itself. That's a pretty cool thing. It shows you the moon is not flat, that area is sticking up higher, and it's in sunlight, and yet the what we see immediately to its left and to its right is not yet in sunlight.
Yeah, and you're basically seeing these crater rims. They're experiencing sunrise right now. So that's a pretty cool effect.
Exactly.
Yeah. Okay. And sometimes now I guess we can now move on from Tycho. Actually, Tycho's right there. Yeah, let me zoom in on Tycho real quick.
Yeah, we can see it in the Earth shine.
Yeah, it's right now. It's not illuminated, but if we let's up the exposure a bit. There we see
There we go.
Tycho.
Yeah.
We move it up a little bit. We can see Copernicus, which is this very old crater here, and Kepler right next to it. And there's quite a lot of craters on the moon, and we can see some of them in the Earthshine, and also a lot of them illuminated right now. So there's a lot of
Exactly.
there's a lot of dynamic range to the moon, where you can see a lot of detail at a lot of different brightnesses. And that makes it a compelling object.
Yeah, and it's one that a lot of people overlook because, you know, we see the moon often and it goes through this cycle every single month. But for people that just want to look at interesting things in the sky, the moon is almost always a good choice, especially in a nice crescent face like this. Lots to see.
Yeah. All right. I think we can start with it's a little bit. Yeah, I think we can start with our first. We're gonna leave the solar system and start with a more deep object. So let me get that into the telescope.
See, we've got some people in the chat, which is nice, and shout out to everybody that's listening in, and Chip and Michael and Jeannie and Fred and Kathy and Woody, and I'm going to miss some names, I'm sure. But yeah, nice to see people talking there and sharing some things. So what's our next target?
Well, it's a little bit early, so we're not quite dark enough for, well, we're not quite that dark yet, so I'm going to go for a brighter object. This one's Messier 45, which is a really nice open star cluster called the Pleiades. And I think people can hear the buzz of the telescope. This mount...
Yeah, that's the actual... Go ahead.
Yeah, this mount's really quite loud, so you'll always hear it whenever I'm moving it. We're going to have to up our exposure a bit.
Exactly, the sound of slewing. Yeah, so the Pleiades is also called the Seven Sisters, Messier 45, and also known as Subaru, and it is a nice open star cluster, that's for sure. In fact, it's the second closest open star cluster to our solar system. It's about 440 light years away. It's likely bigger than your field of view, I believe, yes?
Yeah, it's bigger, but we can see parts of it. I think it's not on it right now. You have to move it a bit.
But we definitely have stars, so stars is good.
There's quite a lot of stars. I think that... So right now, this is our field of view. Let's...
Oops.
It should be like this. And that's our target. So now it's time to hunt for it. There we are. It seems a little bit more like it.
Oh yeah, there we go.
Oh yeah, that looks really nice with the spikes. Oh yeah, there we are. Alright, and we can start live stacking this.
So it's kind of interesting that Charles Messier, he made this list of these things that aren't comets, and some of them, through a small telescope, especially in the days before cameras like this, look like a little smudgy thing that could be like a comet before it gets its tail. And M45 that we're looking at now is nothing like that. It's kind of odd that he added this to his list. Because it's clearly, to your eye, a cluster of stars, even without a telescope. And with the telescope, there is a little bit of nebula that you can see next to a couple of the stars, if your equipment is good for that. But it's kind of odd that he had this on his list, to be honest.
And we can start to see some of the nebula around M45. The reflection nebulas. This is nebula that's reflecting the starlight from these stars, and that makes them glow.
Yeah, you'll notice the stars are nice and blue in color, and that reflection nebula is blue in color too, because it literally is light from the stars shining through dust. So dust in somebody's house isn't very photogenic, but dust out here in the universe certainly can be. And we get these nice reflection nebulae, and it looks pretty impressive. Yeah, we're seeing that pretty nicely there.
All right, let's let that. I don't know. That's kind of weird that the go-to wasn't able to reach it, but.
Well, you found it just fine.
Yeah. So, is there anything in the chat? Why are words out of focus? Do they have names?
Yes.
So, I mean, Stellarium 40 has them named here. So it's upside down here, though. But let's see. Some of these are called. This one down here is called Tagita. We've got Merope, Alcyone. We've got Alcyon's the one over here. We've got Pleione. So they've all got their different names, and even some of the ones that are not part of the 7 still have common names too.
Yeah, definitely.
That's a bit. Ooh.
Here I am supposed to be providing commentary, and I'm doing a bad job of it right now. Sorry about that. So as I think I mentioned, this is the second closest star cluster to our solar system. That makes it a really important star cluster because we can study the nearest clusters to help us understand more distant clusters. And this one's just over 440 light years away on average for the distance of the stars. And yeah, it's a nice target in the night sky.
Yeah, we can start to see we have this really bright.
Yeah. Go ahead.
There's this really bright reflection here, and then we've got some of the more intricate reflection nebula all over it. I think it's getting a little compressed, but hopefully people can make that out. Yeah. Okay. What were you saying?
Well, there was just the comment in there about the resolution of the video going out, I guess.
Yeah. Yeah, that's a YouTube side problem. Okay, I think we can then move on to the other to NGC 1333. This doesn't really have a name, but it looks pretty cool. So we'll get over there if the go-to cooperates.
So both the Pleiades, the Seven Sisters, and this cluster and this target that we're heading for now are both in the constellation of Orion. You can hear the telescope slewing away. So yeah, this one has the fabulous name of NGC 133.
Oh, apparently Stellarium has a
this
name.
one's what's that?
Stellarium has a name here, Embryo. I guess we can call it that.
Okay, I didn't know that.
Well, that's unfortunate.
Everything okay?
Not quite. Let me try to fix that. The mount just did a little bit of crashing into itself.
So I misspoke earlier. I said that this was in Taurus. This is actually over in Perseus. I don't know what I was thinking there. Here the telescope's still moving away, and you see an occasional wisp of star shoot by. I just saw one of those. Yeah, so NGC stands for New General Catalog. Not a great name, but basically they're just numbered objects. So the Orion Nebula, which we'll see later, is NGC 1976. And where we're headed for is NGC 133. Naming in astronomy is actually pretty bad. Of course, people from different parts of the Earth would take the bright obvious things and give them different names. But there are also catalog numbers for things like the NGC catalog. This thing that we're going to see is also called LBN 741. Not a very exciting name either. And part of the problem we get sometimes in astronomy is people don't necessarily realize that two astronomers are talking about the same thing because they were using two different catalogs and different names for an object. Even bright stars can have different names like that. Yeah, there was a question from Corey there about the reflection. I believe the dust is actually between us and the cluster, not associated with the stars themselves. That actually, when I was a kid, kind of a long time ago, people thought it was left over from the formation of the cluster at the Pleiades at 45. But we now believe that it is between us and the cluster. It's not really actually associated with the cluster itself. So, good question. Yeah, another example on the names from the chat there, the HD from the Henry Draper catalog.
Yeah, right now I'm doing a realignment because the mount crashed into itself. So, no idea why I wanted to do that, but it decided it wanted to do that today.
Yeah, this is a thing. It happens.
Unfortunate.
Yeah, and yet we're technologically at a point that's just so far ahead of the way things used to be. The fact that you've got a telescope with a mount that's controlled by a computer is pretty fantastic. And yet sometimes still there can be glitches that cause it to lose its pointing, and then you just have to...
Well, while we're here, there's a very interesting thing about this star right here. This is Mirac. And if you look just above it, let me get that centered real quick, but there's an interesting thing about this object. Never intended to go here, but we're here. Alright, let's... This right here is a galaxy. It's called Mirac because whenever people look at it in telescopes, they see this very faint little gray fuzz right next to this very bright star, so it looks like it's a ghost of the star, but it's in fact an elliptical galaxy that's right next to it. fairly bright for galaxies. So.
Oh yeah, and yet located next to an amazingly bright star, relatively speaking. Mirac's ghost.
And let's see. Here we are. So just to brief on what the current sky is right now, let's turn on the constellation. So we're going to be spending most of our time here because this is where all the winter objects are associated with. So right now we're going to this star, Elnath, and it's between really two of the brightest stars. We've got Capella here, brightest star Auriga, Aldebaran. Pleiades was what we just visited. We've got a very famous constellation of Orion the Hunter. So that's where we're situated right now. Just trying to entertain you while I'm fixing this problem. Where is that star?
That is okay. We are heading in the right direction.
There we are. There's Elnath. Alright.
Okay.
Now we can finally go to what we intended.
Right, it's just a matter of making, it's kind of like if you're driving someplace and you get lost and you need to go and find your bearings, this will do that. Or when the GPS sends you to the wrong place. Yeah. This is what we're doing now. Just getting recentered back on things in the sky.
All right. On our way. Should be there shortly.
Yep. Slewing along. There go the stars streaking by.
Oh, come on, not again. Well, I guess I can course correct from that.
We got hung up again there, did we?
Yeah, it pulled the same stunt again. Maybe this object's just unlucky. Well, I think it's because it's too close to the meridian right now, so perhaps we'll just move on to the flaming star real quick, and then we'll return back when it's a bit lower from the meridian.
Okay. We can do that.
Right, I see.
The Flaming Star Nebula?
Yep.
Yep. This is actually a very cool thing. Some things are cooler than others, but I think the Flaming Star Nebula is actually quite awesome. So we're slewing and we're heading off towards the constellation of the Charioteer, Auriga, I should say. And this is going to be looking at a nebula that's associated with a fairly bright star, a fairly interesting star. I shouldn't say bright. Let me just tell you about the star that we're going to see. It's a pretty impressive thing. It's a star that's significantly hotter and bluer than our sun. It's what astronomers would refer to as a type O star. And it's about 23 times more massive than the sun, and it's 59,000 times more luminous than the sun, which is makes it pretty intense. And it is illuminating a nebula, but not associated with the nebula in the sense of the stars formed from nebulae. Yes, that's true. This one just happens to be sort of passing through the system, so to speak, and it's intense enough that it can make the gas that's nearby begin to glow. Yes, Fred, life in the vast lane. Yeah, later we will look at the Orion Nebula, and there's a little cluster at the center of the Orion Nebula, and it's thought that the star that we're going to look at has been ejected from that. This can happen. Stars pass close to each other and gravitationally interact with each other and get kicked around into different parts of space, get kicked out of a cluster. And this is a high velocity star that you look at the motion it has and sort of point back to where it's come from. That's where people think it's come from, the nebula, the Great Nebula in Orion.
Let's see if this will live stack. I think we're here. Hopefully I'm not wrong. Okay. Nope.
Now we're back to the Pleiades there. So you want to explain what the process is, the live stacking?
So we're basically taking 4-second exposures and we're just we're adding them together to make a better image, so that we can see more of the detail. Especially for this object, you can't really see it right now, but once we perform that procedure, then you'll hopefully be able to see that object clearly. So, like almost every, as I'm going to show later, most of the astrophotography you see is lots of hours of data that's put together and then processed and then it's portrayed. But that takes there's a lot of steps to go through before you get that image, and we're trying to show a little bit of what that's like so we can see some.
Right, we're doing this on the fly. The pretty pictures that you see coming out from the Hubble Space Telescope and other observatories have been pretty heavily processed and often are the result of many, many, many hours of work. And of course, we're doing this on the fly right now with you folks watching. So you notice that the image kind of started off really grainy and hopefully less so as we move along, as we get more signal from the sky itself.
I don't think we're on it. So that's just brilliant.
Dramatic tension here.
Well, there we are. There's something.
The results. Hey, that's the bright star we were talking about.
Is it? Let's check that out. That better be it.
I don't know, it looks kind of orange.
Yeah. If it's this. Yeah, I think it's this. What is it? This is a process.
Yep, it is a process. Just
2 point. Yeah, that's probably that. So to go. So in order to in order to get to our destination. Well, that's nice going on the part of this mount. Right.
So we think we're in the neighborhood, though.
All right.
So the star that we're headed for, as I mentioned, used to be part of a star cluster. And that's the thing. Stars are born in clusters, but they don't necessarily stay there. The sun, for instance, is all by itself in space. It doesn't have any companion stars. And yet it very certainly formed in a cluster as well. And yet we are not part of a cluster anymore. And so close passes between stars can kick stars out. And if a cluster is a relatively small cluster, it just doesn't have enough mass, enough gravity to hold all of those stars together. Bigger clusters with thousands of stars have more mass, and they mutually pull on each other. And it's much harder for stars to escape from clusters like that, as opposed to open clusters like the one that we just saw, and the Pleiades, and like the open cluster that's forming that we'll see later on when we look at the Orion Nebula.
That seems like it. That's literally the same thing. Nice. All right.
Again, the high drama continues as we're slowly working our way to making sure that we're really pointed in the right place to bring out the flaming star nebula.
Yeah, I might have to just redo the alignment again. Because every time it bumps into the mount, it loses its alignment again. So that's part of the why right now lost in space.
Lost in Space. I have some music from Lost in Space. I could play that if we would like. I'm joking.
Yeah, it's only 6:35. I think we should be able to fix this a bit.
Yeah, a couple of questions from the chat. First from Corey. He says that he read that astronomers are seeking our sun, the sun's lost siblings. The trouble with winding back these computer simulations and looking for stars that would be neighbors of the sun, we can't really track it by motion, but we can do it by the second part of what you mentioned there, looking for stars that compositionally are like the same as the sun. The sun, since it's formed, has made like 20 laps around the center of our galaxy. And that's a lot of time for all of the various members of the cluster to disperse. So the other siblings of the sun could be just about anywhere in the Milky Way. And so we do have to look at the elements, the composition of the sun, and look for stars that have that same chemical signature to what the sun itself has. You know, there's a certain fraction of iron and oxygen and other elements that we can measure in the atmosphere of the sun, and we can measure this in the atmosphere of other stars too. And it's not the same for all stars by any stretch. And yeah, so that's what we look for, and people are actively trying to find the siblings of the sun. Fred asks us if this is a high proper motion star. So astronomers use this term proper motion, which is kind of an odd term that refers to the motion of a star across the sky relative to other stars. It's the kind of thing that you can see where a star will slightly change its position over years, usually only with telescopes and photography. This particular star is pretty far away from us, so it's not a high proper motion star, but it has a high velocity through space. So it's moving fast through space, but not moving fast through our sky because it's far from us. Just like you might see a distant airplane, a jet plane in the sky that's really at the other end of the sky, and it might be going very fast, but it might not look like it's going very fast. Kind of analogous that way. This is sometimes referred to as a runaway star. It's moving away from where it formed. Let me just double check something here. Yeah, so it's one of 3 stars that they think have escaped the Orion cluster, the Trapezium. And there are 2 of these stars, and they're separating from each other at like 200 kilometers per second. So now in the chat, we're talking about Lost in Space, so that's exciting. And actually, the modern Lost in Space on Netflix, I would recommend. But I don't know that I could handle watching the original Lost in Space again. It's been too long. So we're still working on getting realigned spatially, is that correct?
Yeah, it's being a little problematic. You'll be able to perfectly go to the moon, and now it's one bump and that's it for it. Right. I think I'll just... Right.
You want to go to a more obvious target and
yeah, let me
sort of recenter from there?
Yeah. Okay. Let's try. How about we let's see what's on. I think we can try the Orion Nebula real quick.
That is always a good target.
Yep. I think it's also fairly obvious.
And it's also one that's easy to find, which is good.
What is it doing?
That's okay. My own personal telescope earlier in the week, I told it to point at a particular place, and it went about 90 degrees from where it was supposed to go. So I was not very happy.
I think there's a problem with the hand. I have to reset the hand controller. I think that's what's going on here. That's always an annoyance. Because I told it to go to M45 and M40, and it started slowing towards the moon.
Oh. And they're nowhere near each other.
Yeah.
We could just do drift scan astronomy. We're doing now. All right, looks like we're moving.
Yes, English. Okay, all right.
Hey, so we're sorry that we've had these technical issues this evening, folks, but we're on to bigger and better things, I promise. Of course, I'm the guy not next to the telescope, so maybe I shouldn't be making promises.
All right, and the time is 1842, and let's finally get somewhere. All right. Now go to the Orion Nebula. Okay, now it's working. We're off. All right, we can. Try for beetle. I was trying for Mira, which is near the meridian. I guess that's also a problem. Right, should be.
Oh, maybe so.
That's not. It's off to Orion. We should see it soon. That's weird. Scott, do you know what this is?
That's the flame.
Hey, what? I told it to go to the Orion Nebula and went to the flame.
So the telescope has targets that it prefers over the ones that you've chosen.
It has its own ideas. Okay, well, I guess we'll do this then and then worry about it later.
We're literally pointing at one of the things on our list, so even though it's accidental, I guess we're staying there.
Yeah. And I was going to make a point about integration with this project, so... Alright, let's get this centered and I guess we'll do it.
Yeah, we went from the Flaming Nebula, the Flaming Star Nebula, which we didn't quite get to the Flame Nebula, which is here in Orion, our bright star. There is Alnitak, which is as you look at Orion, it's the star on the left of the three that make Orion's belt. And the Flame Nebula is what you see to the right of it, right there. We're just getting things.
All right, let's live stack. And
yeah.
Not supposed to be here, but we are here now. Accident happened. Yeah, as you can see, telescopes have a mind of their own at this point. And you just have to go with the flow.
So Orion is such an amazing constellation that with bright stars in an easily recognizable pattern, but it's full of amazing star clusters and clouds of gas. And we've got that in abundance right here. Or we did have that in it, but there we go. Yeah, so we actually have 2 nebulae for the price of 1 right now, depending on how you count. 2 named ones, 3 famous named ones.
All right, so we've got the Flame here, and it's aptly named because it's the Flame Nebula. We've got Alnitak, which is a very bright blue star in Orion's belt. So let's go over there. So if you look at, this is the constellation of Orion. And let me see if we can do some lines. There we go. Turn off the grid. So if you look at Orion the Hunter, the sword over here, that's the Orion Nebula. That was what this thing was supposed to go to. But it decided to have its own line, and we're going to the left star in Orion's belt. And Orion's belt is 3 stars. Over here, this is where you see the Horsehead in flame. And we got a really nice image of here. Really good. So we've got the Flame here, we've got blue star Alnitak. We've got Horsehead, which is a dark nebula that's situated in front of a hydrogen alpha region. So you see a lot of hydrogen alpha gas. And we've got a little reflection nebula pocket here. So this is what we got after just a minute of exposure from dark skies. But I can show you with this same exact camera, slightly different telescope, what you can get if you spend like 12 hours. So that's what I have here. So we're just gonna put that.
Very nice.
Same. So this is the same camera. I took this from home actually, but yeah, this is actually 12 hours. So this is what people do when you put a lot of images together. You can integrate them and you can get a lot of detail out, even in light pollution. But just 1 minute in Julian, and you've got a lot of detail. So that shows how good live stacking is, but also how important, you know, dark skies are.
Absolutely. Yeah, when you've got a better better sky to work with, you can see more. There's no question about it.
All right, now, yeah. So, I mean, it's a little 90 degrees from what we're used to, but yeah, it's pretty clear. So another interesting thing is, when you is dark nebulae, they tend to be transparent in infrared. So when you just so Hubble decided to take an image of this very object. It's a very famous object for that, and when you do that, the dust starts becoming a little bit more transparent because infrared is more easily able to pass through dust. So that's an interesting tidbit. And also we got this streak here. That's from satellites. So commonly in this part of the sky, you get a lot of geostationary satellites. So we've always got these streaks coming through, which is what we have right here.
Yeah, we're pointing fairly close to the celestial equator in the sky, and the geostationary satellites are up above Earth's equator. And so we get them passing through. I had one of my weirdest telescope moments years ago. I was working at a professional observatory in Kansas, of all places, and we were looking at Saturn one night, and I was talking to a young person who was looking through about the moons of Saturn, and they responded by saying, yeah, one of them's moving. And I said, well, they're all moving, but you can't see them move. And he said, no, it's moving. And I looked, and there was this thing drifting across the field of view of the telescope. And it took me a little while to figure out that was a geostationary satellite. But I'm glad I figured it out.
Maybe perhaps we should actually go to Orion now.
Sure. We're in the neighborhood.
Yeah. I'm gonna have to make this telescope not start to have less of a mind of its own.
So this is, as you saw earlier, very near the belt of Orion, and the famed Orion Nebula is in the sword of Orion nearby. And it's what to the eye looks like the
you just have to drift here.
The sword. Yeah. So it's really not a very big movement for the telescope.
Yeah, it just has to go down here. But that's a bit tough for... I think it's probably because there's a bit of error declination. Yeah, okay. I think maybe a part of it is... Right, we should be arriving sooner rather than later. Oh, that looks like something. There we are. We made it.
Yep.
No go-to. Fine. This is like, on what exposure is this? This is 2 seconds of exposure, so it's pretty bright.
Yeah. Yeah, it's the Great Nebula in Orion, and it's the closest big star formation region to our solar system.
So, I mean, in the last star party, we zoomed in a bit in the core, so I'm just going to just try to get more of the outer regions this time. So, let's live stack. To clear out the old stack, and there we go. And it's a very bright object, so we're trying to go for some of the more fainter details surrounding it because it's a very big complex.
It's a large cloud of, mostly hydrogen and helium gas, and it's in the process of forming stars, forming a new star cluster. The brightest region in the middle there is where there's this thing called the Trapezium star cluster. But in this wider view, now that we've got things going, you can see there's a tremendous amount of gas out up towards those bright stars near the top, but also dark material that you can see that's like between us and the nebula. You can see that kind of middle right near that other bright reddish splotch. The red color comes from hydrogen gas. Yet many of the stars, these very young stars that we see there, are the ones especially luminous are really blue in color. So it's not the star light reflecting off the gas or dust. It is ultraviolet light from the stars primarily that's making the hydrogen fluoresce like a neon sign, if you will, only it's hydrogen gas here. It's really one of the coolest things in the whole sky. Oh, and I'm sorry, I'll try to be quiet because yes, the stars, there's sleeping going on in this stellar nursery.
And yeah, it's a naked eye object too. So if you're it doesn't have to be necessarily very dark skies, but if you can see that fuzz around in the sword of Orion, then you're seeing the Orion Nebula. And
yeah.
That's we're already blowing past this set core. So now we can start to see some of the more dust surrounding the object. Yeah. Let's see if there's any questions. All right, I think we should try for M78 since it's also a little bit closer. Just have to go in the reverse direction in terms of scanning. So the horse head and flames right between these two objects, and M78's over here. It's a really nice object.
Oh, M78. Oh, okay. I misheard you for some reason.
Since we're in
that's a good target.
Since we're in the neighborhood right now, and straying from
right.
Probably not the best idea right now.
So the Orion Nebula is number 42 on the Messier list. We saw the Pleiades, which is M45. And we'll be looking here at M78 on this list of about 110 things that aren't comets. Looks like we're back at the flame. But we're just passing through. Oh yeah, so Kathy makes a point in the chat there. She says if you're new to Curiosity Peak Observatory Star Parties, welcome, which I agree, of course, and feel free to tell us where you're from. And Fred asked about the Messier objects. So the first one on the list is the Crab Nebula, but interestingly enough, the list is kind of odd in the sense that you don't find M2 and 3 and 4 all really near each other.
There's the wind.
Messier 2 is a star cluster in the constellation of Aquarius, and that's really nowhere near Orion. And M3 is another star cluster in a constellation that's nowhere near Orion, and Messier 4 is another star cluster, but it's in the summer sky. So it's they were found on different nights in different years, different times of year. Excuse me.
All right. Well, so
we are still on winter break between classes at Palomar College, and I don't normally talk this much, so my voice is already feeling it, believe it or not. Not until we get back into the semester.
All right. So we got M78.
Yeah, and as Woody points out, that not all of the objects on Messier's list were originally found by Charles Messier. That is correct. Some of them were initially found by other people, but he added them to his list. Yeah, so we're definitely at M78 now. That's looking nice, and it's an interesting thing because there's some dark, dusty areas here, but there's this little cluster of stars that has the brighter area around it. That's another of these reflection nebulae. And this object was actually discovered not by Charles Messier, but Messier added it to his list. Again, his list was things that aren't comets, and because he was a comet hunter and that's what he was interested in. And even though some of these were not things he found, he wanted to keep track of them so as to not interfere with his hunting for comets. This is about 1,300 light years away, which puts it in the same neighborhood as the Orion Nebula in terms of distance from our solar system.
And it's part of a bigger complex here, like Barnard's Loop, which is a big, giant, potentially supernova remnant runs through here. And images, you can see that, and there's an amateur discovered nebula that's right here. It's called Mcmurran's Nebula, and discovered by someone who's just trying to take a pretty picture of M78 and suddenly saw something interesting there. And that's
nice.
a variable nebula, so the nebula itself actually varies in brightness, and sometimes it disappears, sometimes it reappears. See. Being a bit of right now.
Excuse me. What's that?
Trying to go to the next object requires a bit of star hopping.
So what are you going to go for next then?
I think I'll try the Rosette, since the Rosette's pretty great, but let's try. It's because the go-to is not functioning right now, so it's a little challenging.
So the question was, and I don't know the answer, but what is the name of that variable nebula again?
Mcmurran's Nebula. So McMairan''S. Mcmurran. Named after the guy himself. I think I can get.
All right. So once again, we are on the move, and we're headed for the Rosette.
I'm heading for. Oh, I'm making a pit stop at Betelgeuse first.
Okay. I can see that.
Let's see if I can get there.
Yeah, we've been having these issues this evening and automatically slewing from one target to the next. But
let me hazard a guess. If I try to slew to the Co-Nebula, it will go to the Rosette. Let's work on that.
Okay.
definitely next time I'm gonna try to use a different mount. Let's see. See, that was successful.
Yeah, it's not always as precise as we'd like.
Huh? Alright, let's see if where it landed.
But we're headed for the Cone Nebula, hopefully.
I'm trying to trick the mount by saying I'll do the Cone Nebula and hopefully it'll land on the Rosette instead. Same trick. Or no, wait, that wouldn't. Oh no, that wouldn't. That's not how it works. Wait.
The wrong offset.
Oh wait, no, it's here. Oh no, yeah, it's the wrong offset. It's the opposite offset. So it landed here instead. That's interesting. Okay. How do I exploit it now? So if I land... So if I slew to the Rosette, maybe we'll make it to the cone. I think that's a better way of doing that.
All right, let's see what happens.
This... Yeah, I wish I could use a Telrad. But that wouldn't really help a lot when it comes to this mount's behavior.
Yeah, for those that don't know, a Telrad is kind of a
Oh, it worked! It
zero
worked!
magnification finder.
Can't believe
nice.
that actually worked. I think that's the Christmas tree cluster, right? But hopefully that better be.
I think so. Down there at the bottom.
Well, let's double check on that. Should be the right member. Yeah, I think I know what
All right, the tension is mounting.
Okay, let's go back here really quickly. It'll land on the flame because that's what it does. And then
Is that where you told it to go?
I'm redoing the alignment, but except... No, I didn't tell it to the flame. I told it to the Orion Nebula and it landed on the flame. So I'm just gonna go with it now. And try to find the Orion again. Then
Okay.
I'll align on this.
Okay.
All right.
Once again, we're back to just making sure that we have
Find
our
things.
bearings. And
All right, and let's center that. And
it's a shame we have to see this again because it's such a terrible thing to look at.
okay, let's now actually go to the Rosette now. Hopefully my trickery has worked on the mount and it will actually start going places. This is the right logically trying to beat the mount. Okay. Now we'll try and see if it makes it there. Then perhaps we can finally see that comet. Break out the staff and quadrant. Yeah. Ha! It's right there. We have successfully tricked a mount into
Nicely
going
done.
where we want. There we go. Oh, it's taking up the entire field of view. That's going to be a really nice object. Let's try to get it in. Yeah, star hopping. No longer have to star hop. Now the mount's functioning once again. So we can quickly run through these objects. All right, let's live stack that. Nope. Run the magic. Actually, I think I'll go with 4 seconds on this one.
This one's a little further out than where we were looking before. The Rosette Nebula is like about 5,000 light years
Oh yeah,
away.
that's... Wait a minute. Is that wind? Okay, I have to... I think it's...
And it's another nebula, but it's associated with a star cluster.
Okay, now it's showing up pretty nicely.
Yeah, which is often the case because star clusters form from nebulae.
Yeah, but this is I'm like the nebula structure around it's showing up now.
Yeah.
It's a bit overcooked. Okay, that's... Alright, we can start to see some of the structure around here. We've got some dark nebula. We've got... Let's see. So we've got this dark nebula down here. Just slewing through the entire nebula, which, keep in mind, is taking up this entire view. And we've got our little part over here. So it kind of looks like a rose, and that's what gives it its name.
Right. And again, this is glowing hydrogen gas, and it's a cluster of stars associated with it.
Yeah.
Whole thing is something like 130 light years across. It's a fairly big object, or complex of objects.
Okay. You want to move on to the next object?
Sure, if we think we'll zoom in nicely on this. So the Rosette Nebula's got like a bunch of catalog numbers as because there's different parts of the gas and different parts of the cluster, but there's NGC 223789 and also NGC 2244 and 2246. All of those are associated with...
It's quite common for a lot of objects that have
the nebula
multiple...
in the cluster.
It's quite
Yeah.
common for a lot of objects that have multiple different sections, or so that they can try to figure out a way of naming it. Or when they used to think that they were different objects. And sometimes it's just that, you know, some of them get two names because accidentally sometimes. That's the case for like one planetary nebula, which is NGC 2371 and 2372, despite not being, besides being one and the same object. So catalogs are sometimes a bit messy. Alright. Let's get to this one. Christmas tree. It's a bit late because we're way past Christmas, but there's a Christmas tree cluster. It's right there. The bottom star's supposed to be like the trunk. And then the tip of the tree at the very top is a nice little nebula called a cone nebula. Kind of like an ornament. At the very top, like an ornament. So
Hey, I was kicked out, but I am back.
yeah, we're on the Christmas tree cluster right now.
see that.
It's really this
But it's January.
Yeah, we're a bit late.
Sorry, I had to say it. Please forgive me. Anyway, I think I was answering before when my connection went away, or in the Rosette, the cluster there is very much associated with the gas cloud, and the star formation is still happening. And it's the young stars that are making the gas cloud fluoresce, just like in the Orion Nebula. Only here, it's an older thing, and the cluster is kind of cleared out gas in the middle. But the Christmas tree cluster, that's kind of in the neighborhood there.
Oh yeah, we're already starting to see the cone there. And there's this big blue reflection nebula. Looks really pretty over here too.
Oh yeah.
Right, there's our view. It took us a while to get really into gear, but we're on our way.
That's the Cone Nebula near the top?
Yep, over here. If you can
Yeah.
see that cone shape over here, and we've got this blue splotch here. And this is like the general orientation of the Christmas tree. Here we got the trunk. So this is a 48 seconds, so if we let it stack a little more, we should be able to see it more clearly. Alright.
Yeah, these were discovered by William Herschel, the same guy that discovered the planet Uranus. It's about 2,600 light years away. Well, depends on who you talk to, actually.
It's part of a huge complex. It's part of a pretty big complex in general. In here there's a lot of hydrogen gas here that surrounds us completely, this entire area, and it's a little bit. But this is basically the part that most people focus on. Is this star cluster, very distinct shape, and we've got this cone, got some reflections. So and there's some dark nebulae across this reflection and across this entire field. So we've got many types here.
Yeah, it's a nice view. There's a lot going on in this region of space, that's for sure.
Okay, I think we're starting to see it more clearly now. We got the cone.
Yeah, so again, most of these are pretty young stars, and there's that Cone Nebula, which is the dark area up there that was pointed out earlier near that brighter star.
Okay. I guess we can move to the next object. Let's see. So, guess we can.
Which one did you want to go for?
I guess we can go for dryers. I think that's pretty bright, so.
Okay, this one I actually know like nothing about.
I mean, it's a reflection.
It's okay, I'm not complaining, I'm just saying.
Yeah. Okay, let's stop this. Reset. Alright, let's move. It looks really pretty though. Which is generally the trend we're going for. Very short hop.
Yeah.
I think, did we get there?
Interestingly enough, when you search for this nebula online, the first thing you get is hits for ice cream. So
I think, isn't Dryers the ice cream brand?
It is a brand of ice cream, yeah.
I guess that would explain it.
Yeah. That's because it's very cold in space.
Just a quick joke there.
Sorry.
I think this is it. I hope I'm right. Yeah, there's a little blue stuff there. If you see blue stuff, very likely might be onto a reflection there.
Oh, oh yeah.
Okay, we gotta get rid of the cone and we can start life stacking this. Oh, that's very blue enough. And then we can start to see the noise just kind of fade out into the background so we can pull out this object. Yeah, there we go. This big blue patch of reflection nebula. We got a little bit over here too on this right side.
Mm-hmm.
It was named after an astronomer. Last name Dry. I actually forgot his first name. I think it's Norman or something.
I don't know. Yeah, usually whenever you see some nebula that's bluish, that's a reflection nebula.
John Luis Emil Dreyer. That's his name.
Oh, okay.
He found this in space and got his name on it, so kudos to him.
Indeed.
Oh yeah, there we go. There it is.
Yeah.
Yeah, it's the same pattern reflection, so every time we do something like this, we're always talking about the main types of nebula. So this one's one where we got dominated by reflection.
Right. So when we talk about dust out in space, it's not the kind of dust that might be in somebody's home, but more like what you might encounter if you're driving on a dusty road. It's more like mineral grains or carbon grains than dead skin cells, which would be seriously creepy. Hey, there's a question about your camera, Vivek.
Yeah. It's CMOS. It's an ASI 5. If you know what the designations for astro cameras, it's an ASI 533 MC cooled. It's actually, in terms of CMOS, it's one of the latest generations, so it's got no amp glow, which is a great help for us, and it's pretty sensitive, which is great for doing something like live stacking. A CCD for live stacking would be a bit problematic because we're trying to take really short exposures, especially when we've got things like wind or the fact that I'm just using this mount, just tracking, no auto guiding or anything, where you basically lock onto a star. And CCDs have a type of noise that's very high when you take short exposures. So for doing something like this, we would use CMOS. But in general, it's very common for professional astronomers to use CCDs because they're very consistent, and they're very consistent compared to how CMOS are read out.
Right. And when you're doing science, that's completely what you want. You want to know what the universe is telling you, and to understand that, you need to know what your camera is telling you. And the fact that as you said, they're very consistent, that means they're very repeatable. That's very helpful in understanding things. They literally would take what are called dark frames, pictures of dark, just to see what the readout of the camera is, so that you don't mistake anything from the camera for actually being something from the universe itself. Yeah, many of the digital cameras have CMOS chips in them.
Yeah, CMOS has been entering the market. It's recently started taking over the amateur astronomy market, and it's basically becoming the camera of choice for amateur astronomers. And
Yeah.
there's also a lot of CMOS applications for professionals, but it's a lot slower because professionals have really big standards, and usually when they build cameras, they can afford to build custom chips, and CCDs are great are right now what would be the best, but the technology is still evolving, so you might see more of that, more CMOS in the future.
And other things. You're right. The technology is absolutely evolving. And virtually all of the cameras used at observatories are custom cameras built specifically for that observatory. Very rarely is there anything that's off the shelf that people use.
Like
What,
one of
go
the
ahead.
one of the only examples of CMOS I personally know about is in the Herschel Space Telescope, and that's an infrared telescope, and they use CMOS, and they did it for a very specific reason. It's because they needed to take very short exposures in order to be able to eliminate heat noise. So it's like short exposures, those are kind of a realm, because CCDs have a problem with doing very short exposures, so they chose CMOS for that application, and it worked very well for them. But that's one of the only instances where I've heard of CMOS being professionally used on a large scale as one of the main parts of a instrument package. And also, we've finally made it to the flaming star, hopefully.
Aha. That was our nemesis earlier.
Hopefully, we're somewhere in the ballpark.
Yeah, it used to be, as Fred pointed out in the chat, that CCD chips were very small and very expensive. Yeah, that's for sure. Years and years and years ago, I had an observatory at the high school I taught at, and we had a CCD camera that had a very tiny field of view and a telescope where images would change, like the image of a star would change its position when you focused, and it would, as you adjusted the focus, the object would go out of your field of view. It was very, very, very frustrating.
We actually made it.
Yay! Hey, we're finally back, this time for real, at the Flaming Star Nebula. This is the one that we got lost on before, and I was saying was a star that probably escaped from the central region of the Orion Nebula cluster. It's this high velocity star that's flying through space and is currently illuminating this cloud of red gas that you see filling into the view.
If you look very carefully, there's some blue in here, and that's because we've also got reflection in here interspersed with the hydrogen alpha emission.
Mm-hmm.
And here's a common thing. So there's this common thing that amateur astronomers sometimes do wrong is when you see blue in space, it could mean reflection, or it could mean like oxygen 3, which is just like teal bluish, somewhere in that part. So a lot of people, in order to image this object, they use narrowband filters, which only concentrate on the specific emission line that that emission nebula are reflecting, such as hydrogen. So when they put an oxygen filter, they're assuming this blue stuff is oxygen, but in fact it's reflection. So that's a common thing that amateur astronomers sometimes get tripped up, and that's why for even astrophotographers, kind of understanding the nebula is important to be able to successfully photograph it.
Right, and all of the professional astronomers are doing usually narrowband photography with filters like that, where they're honing in on a particular wavelength. Many of the Hubble photos that have these greens and things that you see, and then make use of that. But it's always good to make sure you're choosing the right filters, or you won't see what you want to see. That's for sure.
Like to recap again, this is a AB Reggae, which is this bright star here. That's an O-type star, and it's very, very hot. It's able to the ultraviolet radiation is able to make this nebula glow, the emission nebula.
Right. Yeah, this is the one that's 59,000 times the luminosity of the sun.
O-type stars. It's like the O-type is the category
Hottest.
to the hottest and the bluest stars. So.
Right.
And we don't see them if you're looking randomly in the sky. You usually don't encounter them. It's so. There a lot of speciality to them.
Yeah, they don't live as long as the other stars. These more massive stars burn through their lives faster, and so we usually see them associated with nebulae. This one just happens to be next to one it didn't form from. And one of the questions on the chat was, or comments on the chat, that he's read that some stars are moving so fast they will escape the galaxy, and that's absolutely true. There are high motion stars that are going to leave the Milky Way.
And another question, is a star currently in Orion? If you're referring to this one right here, we're right now in Auriga, which is, I think that's a chariot. It's this constellation here. It's it's like a hexagon, except not really. It's more like a pentagon.
Like a poorly drawn one.
Yeah, and it's like it's left of Taurus, where you see Aldebaran and the Pleiades. And it's a bit to the north of Orion.
Yeah, you can find it because there's that really bright star Capella that's high in the northeast.
Yeah. We're actually going to go near that soon because that's where the comet is.
Ah, that's right.
So I think you can see this complex here. Lots of blue. We got some hydrogen alpha. We got this little structure here. So I think we can now try to go visit the comet now.
Excellent.
Yeah, the comet, if you want to see the comet, it's magnitude 12, so it's not like a naked eye comet thing. You need a telescope to see it, so just want to make that clear. But sometimes we do have comets that are naked eye, which was quite recently the Neowise. That was
last summer.
When that kind of stuff happens, people really start paying attention to what's going on in the sky.
So the comet is Comet Atlas, but there are other Comet Atlases too. Atlas is an acronym, ATLAS in all caps, and astronomers give them catalog number names too. So this is C2020 M3 Atlas for its full name, which is really doesn't roll off the tongue very well. But if you want to know, it's moving through our solar system in its orbit, and it is currently about 81 million miles from Earth, and relatively far from the sun as well. So
there's Capella, very bright star.
So that's not the comet, but we're in the neighborhood.
Break out the 40-inch. Yeah, I mean, according to the website where I'm pulling this coordinates from, they say it's visible to 6-inch. I highly doubt that, but I mean, magnitude 12 isn't that horrible, but it's certainly not bright.
Right, you're not going to step outside and see it like Neowise was. Yeah, and the comet is also moderately far from the sun, so it's actually farther from the sun than Mars is, so it's not super close to the sun. So it's not amazingly close to Earth, it's not amazingly close to the sun. Both of those things would make it brighter if it was that way. But it is in the sky, and hopefully we can catch it here.
All right, so we're right here, and the comet's around, so a little bit north we should see it. So let me zoom to make sure we're north. All right, so we can. Yeah, I'm not sure I can exactly just punch in the coordinates because the go-to's acting a bit up right now. Okay, well, I think we should retrace our steps a bit. Okay, we have to go a little bit.
Excuse me. Yeah, it was closest to the sun late last year. Let me see if I can find how long it takes this comet to orbit the sun. Oh, it has an orbital period of 138.9 years, according to JPL.
So the way this works is, let's do this really quickly. All right.
Now, this comet, like many others, doesn't necessarily orbit in the same plane as the planets do. What's called the ecliptic. Its orbit is actually tilted, which is why we're looking ecliptic here.
All right, let's now I can
Is it in the data?
Just go there directly. Will this allow me to just go there directly now, instead of just trying to scout around? Alright, so that's 05. Right now I'm punching the coordinates to this comet instead of just hopping around for it. Hopefully the go-to likes me. 11:46. Okay. Then we don't think that's working out too well. Yeah, it's not that far away from the... That's weird. Somewhere there.
All right, I was cut off there for a moment, but I'm back. How are we doing?
Still trying to find it.
Yeah, it's a faint one.
I think it is there, it's just that it's really faint. Okay. Well, I know where I am right now. So it should be entering the field of view now. Oh, that's deathly faint. Okay, we definitely need to live stack this one.
Yeah, I would say so.
Yeah. Okay, let's start that. It's somewhere here. Yeah, this is not a naked eye comet, that's for sure.
Correct.
Okay. Usually when we try to look for comets, the signature is, it looks kind of greenish. Something like that.
Correct.
Greenish blue. And that's from carbon. A lot of carbon compounds, especially carbon, diatomic carbon. That has a lot of what we call swan bands in that part of the electromagnetic spectrum. So let's try to zoom in and see if we can spot it. So if we're
also looking for
imagine
fuzzy.
if people trying to find comets. Oh, it's there. That is the comet. Okay. So maybe some of you are expecting something a little bit less, something more dramatic, but it's right here. It's a little tiny little thing right there. Can you see that?
I can.
It's right here.
Yeah. That is a ball of ices and carbon compounds. So, like frozen water,
this is
frozen
correct.
ammonia, frozen carbon monoxide.
It's definitely corresponding to the location, so we're actually right there. So, yeah, this is what kind of like what comet hunting is like. You have to look for objects that are not supposed to be there, like they're not stars, they're transient. So, yeah, we're spotting that comet right here. It's a little bit tiny right there. And yeah, so this is really faint. It's according to Stellarium, it's magnitude 16, so it's actually quite faint. But they get brighter. Right now, this comet's heading away from us, so we're basically say its last goodbyes.
Right. And given the orbital period, I don't expect any of us to be around for the next passage of the comet.
Yeah.
It's certainly not me. But yeah, it's out past the orbit of Mars, heading farther from the sun, and we have sent several space probes to visit the frozen center of comets, what's called the comet nucleus. And most of them are kind of peanut-shaped. One or two frozen lobes of material together that are very, very, very dark, like as dark as coal dust. But as they get close to the sun, the heat energy of the sun begins to vaporize the frozen material there and lift off some of the dust. And that creates a little atmosphere around the comet, which is what we're seeing here, called a coma. And that can also lead to producing the tail of the comet.
So it actually looks like, actually looks like this is actually magnitude 16.7. So, yeah, I think probably what I was looking at was overestimating it way too much how bright it was. But, you know, we're getting 3 minutes of data. We're already spotting this really faint, diffuse magnitude 16.7 apparently comet. So, that's dark skies. Yeah. I think we can go. We're getting close to the end, so we can visit just a few more objects now.
All right.
Okay, so we're gonna say goodbye to this comet, and let's back to some more. Let's see, this one is I don't think we can do NGC 1333 because it's on the other side and it's probably going to do the bumping maneuver. So.
Okay. Were you going for?
We're going for the monkey head, and then we'll finish off with the final object, Monoceros IR2. So. Let's quickly go see the monkey head.
Yes, the Monkey Head Nebula.
This is so. I guess before Lynn was talking about me doing some photography stuff. This is one of the objects I imaged that got me money. So object.
You going to tell that story?
Oh, yeah, I photographed it and then I submitted it and I got money. I mean, okay, it's a little more complicated than that, but you basically, it's like doing it with narrowband filters where you're looking at it in the specific lines and using that too. And then you combine that, and there's some artistic license to how you combine it.
Right. So was this for an astrophotography contest or a science project or
astrophotography contest, not a project?
Okay.
Usually usually astrophotography doesn't do a lot of science unless you're really lucky.
Or trying really hard.
Yeah. Like a lot of
Are we there?
targets are usually going to be a little bit more boring than something you want to put on a gallery or something.
Sometimes, yes. For science,
yeah.
Usually.
Yeah. Sometimes you can visit interesting things though. Like
absolutely
interesting to look at least.
So you should already see some nebula in here now, huh?
Yeah, I haven't. I made a mistake. It needs to take 4 seconds.
Oh,
like there we go. Now it should do it. Okay, there we go. That's more like it. There we are.
And you can even see the face, kind of, to make it the monkey head?
I mean, personally, I haven't. Apparently, my parents can see the face. I can't see the monkeys, so.
Okay, so there are two bright stars near the middle, yes?
Yeah.
And then left of the leftmost one, there's like a dark roundish area. That would be like an eye.
Yeah. So.
And then there's another roundish area.
Oh, I see it. I see it. Okay. Yeah, I see it.
There you go.
Well, yeah. Actually, this eye part you're referring to, that was photographed by Hubble. Like this specific little area. I can. Just to demonstrate what Hubble's field of view is, it's just basically this one little pillar right here. This one little pillar. That's the entirety of Hubble's field of view. Because Hubble took a really nice picture of just this.
As in the Hubble Space Telescope, yes.
Yeah. Right there.
Yeah, so when you see the pictures from the Hubble Space Telescope, you immediately think, why is this called the Monkey Head Nebula? And it's because it's like you're looking at an eyebrow.
Yeah.
Compared to an entire face, you wouldn't necessarily recognize it as.
Yeah,
as
Hubble.
Now, while this is certainly much less convincing than, say, the Horsehead Nebula in terms of the name, I think you can see some resemblance to a shape there.
Yeah, and another thing is Hubble has to have there's a lot of advantages. Hubble is a really big telescope, so that has for optically, they has to have a pretty long focal length, which is why it has such a small field of view. But it also gives a lot of resolution, especially since it's in space and it's free from atmospheric distortion. It can really see a lot of great detail on even really young planetary nebulas, things like that. So there's our pretty pictures. We'd like to get the entire nebula, but sometimes people go really high resolution and they can just look at just portions in the nebula or going with something like that.
And of course, from space, it's even darker than it is in Julian.
Yeah.
Not a crack against Julian, because even if, it's just darker from space, that's for sure. Part of the reason to have telescopes in space.
Just gotta wait for James Webb to launch at some point.
Yeah, so theoretically in October, on Halloween of all dates.
Theoretically, of course.
Yeah.
Oh. Okay. Alright, I think we'll move on to the NGC 2170. I like the
Oh, okay.
oxygen.
Sure.
Yeah, that's kind of important to have oxygen. Sure.
Yeah. Yeah, there's certainly much more breathable air in Julian than in Earth orbit. I always tell my students that if there's a problem with telescopes, say here on Earth, like at Palomar Observatory, I mean, there's staff that lives there that can go and fix this thing. It's definitely
Well,
not
that's
the
a
case for
miracle.
us for our orbital telescopes.
Did it actually make it there by itself?
You think so?
We'll see if it shows up in exposure. No, not quite. I think.
So we're at NGC 2170.
We're trying to get there. That's
Yeah, that's what I meant.
all right. I'm right about this. We should be there soon.
It's a relatively small nebula, I think.
Well, it's just a really, really interesting complex. Like it's pretty confusing, I would say, but it's really pretty. I think it's called the Angel Nebula colloquially.
Yeah, I read that.
Guess the problem is just getting there now.
You're madly slewing across the sky here.
Slewing, yeah, I would agree.
Always tricky to compare the field of stars that you see from your camera to the field of stars that you see on your Finder chart or your software. Sometimes it can be a little difficult to recognize a pattern, especially if something's turned one way that you don't quite expect. Just to make sure you're pointing in the right place.
That's always a challenge.
Yeah. I have seen many professional astronomers when I worked at Palomar Observatory with Finder charts that they had like overlays to go over their laptop. They were like getting a picture from the 200-inch telescope, but not quite sure where they were exactly pointing and trying to pick up their laptops
Now,
and
we
turn them
right now
sideways. And
the way
all
we
kinds
have
of things.
astrophotographers right now, the way we have it is we can use plate solving, and that makes a lot of things easier.
Yeah.
Problem is for tonight, had to forego that capability, which is now being a little annoying, not having that capability. So it's a lot of bouncing back and forth right now. Try that again. This is supposed to correct. It's not doing a very nice job of that. Gotta see
But
what
it's
it is and where it actually
drama.
is.
I don't know if anyone else has any questions they wanted to ask from the chat while we're trying to hone in on this.
Yeah, this is gonna be the last target, so maybe try to where it is.
Yeah, I think we're
We're out of target. Oh. Perhaps we'll see how much I'll try to go to the. We'll revisit our favorite nebula again and see how much off it is right now on this. The other thing about this mount, the way it's designed, is that the offset kind of depends on where you're on the sky, which makes the star hopping a bit more trickier. Okay, that's weird. What? Okay, so right now it's spot on, which is that's confusing. Maybe we were on the object the entire time.
Well, let's go back and take a look.
That's weird. Could be a trick of orientation, of course. Then we were on and try. Maybe it's up in the corner.
I think.
Celestron has plate solving with the star system. It will, yes. Actually, you can plate solve on a Celestron mount with a computer, with just general. The reason why I'm foregoing it is because of cable problem issues stuff. And StarSense does work on equatorial mounts.
I think we're maybe pretty close, yeah?
I think it's here, yeah, we're here now.
Yeah, I think so.
Nope, wrong direction. Okay, this is the final object for the night, and we're so close. Just gotta get it in. Right, is that it? Yeah, that is it, okay.
Yeah, I think so.
Okay, there we go. Just gotta get one more center.
All right, let's take a look.
Live stack. No, wait, I have to do it 4 seconds. I forgot about that part. Right. Yeah, the thing is it's reversed right now, so
Yeah.
the tripping off point. But so like to talk about the plate. The reason why I'm not using plate solving again is, which I wish I was, is because is actually because the hand controller that I'm using right now it's available, and it's kind of the RS-232 part is kind of the cable. It doesn't work. So the actual one that would work is actually with Doug right now, and he's arriving today. So for now, I just have no plate solving for today, which is a bit coincidence, but I thought the Starline was enough.
But we're making it work. You're making it work.
Yeah. All right. I think it's a little bit faint, but I think we're starting to see it. But basically, what we ought to see right now is there's a lot of reflection nebulae around these 4 stars, and as we integrate, we should see more of that. But there's a lot of I think dark nebula starting to show up now.
Mm-hmm.
There's dark nebula around these parts, and they show the RS-232 really archaic. Yes. Not. It's actually really common for mounts amateur astronomy to use RS-232. So it's only recently that they've started to come to the 21st century. Now a lot of mounts, they actually use USB, but a lot of them just use RS-232 right now.
This is it. I mean, it's our live virtual star party where we can talk about the universe and cables. That's what our audience comes for.
The cable talk.
Hey, you're on Cable Talk. You're nice.
So, I think it's a little more fainter than I expected, but we can see some stuff-ish. Not as impressive as some other objects, but... Alright.
It's the Angel Nebula.
Yeah. I'm not sure how this looks like an angel, but I'll take it. I think maybe I have the angel somewhere here. There we are. There's the angel. Yeah, this is a different telescope, but this is what I took of it. It's right now flipped, so let me actually so you understand how it's oriented right now. So, again, these things require hours of data. So, let's see.
Yeah, the question was, what ISO is your camera operating at? But I'm not sure that's
the right term.
Question.
So here's the thing. ISO is like a term that DSLRs use for gain, which is what it's a value that determines what the amplification is on the sensor itself. So to help control the effects of read noise. So that's a bunch of sensor crap. But basically, this is probably one of the highest gains, and I really shouldn't be doing that. The only reason I'm doing that is because so I don't have to do less stretching here. But usually when people live stack, when they have a normal like camera that's not variant, you try to go for really high gains because you're doing very short exposures. But on this camera, there's a read noise drop at 101. So technically, when you're photographing with this camera, you should always be at 101 no matter what, or 100 technically. But I mean, I'm just doing that for stretching reasons to get it to 500. But anyways, this is the Angel Nebula. It's oriented like this. So hopefully you can see the correspondence. This is like 12 hours, which is why it looks a little more substantive. And this is only like 5 minutes, but...
Yeah, we're not going to be live for 12 hours.
Yeah.
Sorry to disappoint anyone.
Yeah, but I think...
That's a pretty spectacular shot, though, that you took there on the right.
But I think we can continue here. So hopefully we went through a lot of objects, and there's a little bit of technical difficulties with this mount, but we got through it. So I think...
Yeah, thanks for everyone for putting up with that, and thanks to everyone for joining us this evening. It's always good to share the universe with people, and we're not doing that in person now, but we're glad you were able to tune in from your home or wherever you happen to be. And I would say, look for more announcements of further star parties in the future, and more cool bits of the universe for you to see.
Yeah. And we're starting to head further into the winter objects during the evening, so we'll hopefully cover some more of those.
Yeah, there's always something good to see in the sky.
Yeah. Okay. All right.
Well, good night, everybody.
Good night.
And thanks.